Bias mitigation always sounds clean in a slide deck, but then you look at the data and it's just a garage sale of uneven classes. Half the problem is the model learning that the loudest group is the whole world.
Yeah. If one class is rare, the loss barely cares unless we force it to. Then the model gets very confident about being wrong, which feels efficient in the worst way.
Exactly. Class reweighting is the first blunt instrument people reach for. Give the rare labels more weight, punish the majority a bit less. Sometimes it helps, sometimes it just teaches the model to overcompensate like it drank 3 espressos.
But if the imbalance is extreme, plain weighting can make training unstable. I'd rather check whether the minority class is actually undersampled or just noisy.
Fair. Though I'm suspicious of any dataset where the minority is also the only class with half the missing labels. That's not imbalance, that's negligence wearing a name tag.
We could pair weighting with resampling. Maybe not full duplication though. Overfitting the same examples 20 times is not exactly wisdom.
Right, because then the model memorizes the rare cases and starts hallucinating confidence. I've seen that movie. It ends with metrics looking great, and production looking like a haunted house.
A better approach might be effective number weighting or focal loss, depending on whether the hard examples matter more than just the rare ones.
Now you're talking. Though every time someone says focal loss, I think they're about to hand me a camera lens and a spreadsheet. Still, weighting only treats the symptom. If the features themselves are carrying the bias, the model can stay lopsided no matter how nicely we balance the loss.
You mean proxy variables, like zip code standing in for income, or browsing patterns standing in for something a lot messier.
Exactly. The model doesn't need the sensitive attribute if some convenient little cousin of it is hanging around in the features. Very polite of the data to hide the problem for us.
So feature selection becomes part of mitigation, not just model tuning. Drop obvious proxies, or at least test which variables are too correlated with protected attributes.
Right, though I'm wary of just deleting features blindly. Sometimes the proxy is also genuinely predictive. Then you're trading bias for a worse model, and everyone pretends that's a philosophical victory.
Maybe use a smaller audited feature set first, or compare importance scores before and after removing suspicious variables.
And watch for combinations. Single features may look innocent, but together they can reconstruct the sensitive stuff like they're building a profile from flea market scraps.
Which is kind of what we're doing with the data, just less charming.
Less charming, more expensive. But if we can cut proxy bias early, the rest of the pipeline stops arguing with itself so much. That's the annoying part. Even after feature cleanup, you still need a metric to prove you didn't just move the bias around.
And there isn't one metric that solves everything. Accuracy can look fine while one group gets crushed.
Yep. Then someone asks for demographic parity, and someone else points out it can ignore actual label differences. Suddenly the room gets very quiet.
Equal opportunity feels more targeted if false negatives are the concern. But then you might lose calibration.
Right. And calibration matters when the scores drive decisions. I hate when people treat fairness metrics like menu items. I'll have one parity, hold the trade-off.
The hard part is that the metrics can conflict. Improving one can worsen another, especially if base rates differ across groups.
Which they usually do because reality enjoys making clean comparisons impossible. I've seen teams chase a single number and accidentally optimize for the wrong notion of fairness.
So we need to choose based on the harm we're trying to prevent, not just what's easiest to report.
Exactly. And we should always inspect group-level error rates, not just the headline score. Otherwise the model looks balanced from far away and deeply unfair up close.
Like those bargain watches that look elegant until you read the actual time.
If metrics are the report card, pre-processing is where we try to clean up the classroom before the test starts.
Revying and resampling fit there too. But there are other options. Maybe normalize or transform features so one group isn't effectively getting punished by scale differences.
And maybe repair the labels if the historical data is biased. People love pretending labels fell from the sky. They didn't. Someone clicked them.
Though relabeling gets tricky fast, you have to separate noise from actual structural bias, and that can become a very philosophical bug report.
Preprocessing is appealing because it's model agnostic. You fix the dataset once, then every downstream model benefits. At least in theory. In practice, somebody changes the data pipeline on a Friday.to.
Of course they do. You can also use representation learning to project data into a space where sensitive information is less recoverable.
Less recoverable is doing a lot of work there, but it's useful when raw features are too entangled to prune cleanly.
The trade-off is interpretability. Once you start transforming too much, it becomes harder to explain what the model is actually seeing.
Which is ironic, because we pre-process to make the system fairer, then we have to defend it to legal, product, and 3 skeptical engineers with coffee. At some point, though, pre-processing hits a wall. If the model can still infer protected information from whatever's left, you need to teach it that trick is unacceptable while it's learning.
That's where in-processing comes in. Adversarial debiasing, for example, tries to make the predictor useful while an adversary fails to recover the sensitive attribute.
Right. The model learns be good at the task but don't leave fingerprints. Very spy thriller minus the trench coat.
It can work well, but training gets more delicate. You're balancing two objectives, so if one gets too strong, the whole thing can wobble.
Exactly. I've seen setups where the adversary becomes so weak it's decorative, and others where it wins too hard and the main model forgets how to predict anything.
You need to tune the adversary capacity, the loss weights, maybe even the update schedule. Otherwise, you're just playing tug of war with your own optimizer.
And if the data is noisy, the adversary may latch onto the wrong signals anyway. Then you get a fairer model by accident, which is not a strategy I'd recommend in front of auditors.
Still, when feature-level cleanup isn't enough, it's one of the few ways to bake fairness into the learning process itself.